Hello students, welcome back to Physics with Safdar. Now you are watching IGCSE Physics Past Paper Solution series. In this series, we solve questions from paper 2, 4 and 6. If you are facing any problem in your IGCSE Physics, so you are at the right place. You can find the solutions of all your problems. I suggest you follow the playlist of the channel and keep in touch. Physics with Safdar for better results in exam. Today we are going to solve question 9, 10, 11 from Specimen 2020. So let's start the solution. This is question number 9. A plastic rod is rubbed with a cloth and becomes positively charged. After charging, the rod is held close to the suspended table tennis ball shown in figure 9.1. The table tennis ball is covered with metal paint and is uncharged. Look at the diagram. This is positively charged rod and light tennis ball covered with metal paint. And this ball is suspended by using a nylon thread in part A. Describe what happens to the charges in the metal paint on the ball as the positively charged rod is brought to the ball. It is given this light tennis ball is uncharged. Uncharged means they contain equal number of positive and negative charges. So you can see here like this. Then what happens when you bring a positively charged rod close to this metal sphere? These negative charges or electron move towards the right side. You can see here. So you can write here when a positively charged rod is brought close to the ball, negative charges or you can write electrons move to the right or towards positively charged rod. Part B. The ball is attracted toward the charged rod. Explain why this happens given that the ball is uncharged. Of course it was given the ball was uncharged, but when you bring this positively charged rod close to the table tennis ball covered with the metal paint, you know well negative electrons move to the right. So because of that, what happens? The positive charge appear to the left hand side. So negative charges or electrons and positive charge rod attract each other, because you know well unlike charges attract each other. So because of that, the sphere moves towards the charged rod. So you can write like this: negative charge negative charges or electrons are closer to positively charged rod and they attract each other and what's the reason why they attract? Because of unlike charges characteristics, they attract each other. Part C. State the unit in which electric charge is measured. You know well every physical quantity has a units for its measurement. So this type of question you need to learn the unit of different quantities. Electric charge measured in coulomb, so you can write here coulomb. or short form C. Electric charge measured in coulomb. Question number 10. Emission from a radioactive source pass through a hole in a LED screen and into a magnetic field as shown in figure 10.1. The experiment is carried out in a vacuum. So look at the diagram. There is a radioactive source that contain unstable nuclei. And you know well, unstable nuclei to get stability emit energy or radiation in the form of alpha, beta and gamma. This is the LED screen and you can see cross. These cross indicates a magnetic field region. Cross means the direction of magnetic field into the page or inside the surface. And you can see some points at this side, point A, B and point C. Now what we have, radiation detectors are placed at A, B and C. They give the following readings. You know well, radiations are invisible and for their detection we use a special type of detectors. So at point A, B and C they place detector to record the radiations. And what are the observation recorded? Look at this one by one. When the detector is placed at position A, 32 counts per minute recorded. At position B, detector show 543 counts per minute. At position C, 396 count per minute. Then radioactive source is then completely removed and the readings become. In the second part, after removing the radioactive source, once again let's check what are the detector is recording. At position A, it's recording 33 counts per minute. So compare with the first one, with source and without source. So there is no a big change in the number of counts per minute, keep in mind. Second one, this time the counts are 30 counts per minute. If you compare with the first condition, it is very clear. After removing the radioactive source, the counts decreases 543 to just 30 counts per second. At C, look at this. Now the count recorded 31 counts per minute. If you compare with the first one, it's very clear. In the presence of radioactive source, 396 counts per minute, and after the removal, we are getting 31 counts per minute. Remember one thing, after removing the radioactive source, you are getting some counts on radioactive detector. What are these counts and what are the reason? Remember one thing, these count because of background radiations. Background radiations are the radiations present in our atmosphere all the time. And because of this radiation, the counter detects few number like at position A 33, 32 like that. Now what is the question we have? Look at this part. From the data given for positions A, B and C, deduce the type of emission coming from the radioactive source. Explain your reasoning. Go back. These were the positions A, B and C. Now you need to use their observation counts per minute to write what type of radiations are detected at this point and with justification. So let's start with the position B first. At position B, the radiations are received are gamma. What's the reason behind it? Look at the radioactive source and this opening. The radiations are received at B straight, undeflected. And you know well, gamma radiations are uncharged radiation. That's why they do not deflect in a magnetic field region. And we receive at position B. Now discuss point A. Point A, look at the count rates 32 and 33. Almost they are same in size, and these are the count rates recording absence and with the presence of radioactive source. That means these are background radiation, not because of any kind of radiations from the source alpha, beta or gamma. At point C, look at what would be the track of radiations from radioactive source to reach point C. It's like that. They deflected. What does it mean? It's very simple. In magnetic field, when a charged particle move, positive or negative, they deflect. It confirmed that the radiation they are receiving at point C could be alpha or beta, because alpha particles have positively charged and beta negative. How can you differentiate at C receiving alpha or beta? That is very simple. Oppositely charged particles like alpha and beta behave differently or deflect in the different direction. By using the Fleming left-hand rule, we can recognize these radiations are receiving are beta in nature. So you can write the detail of the answer like this. Question number 11. In Geiger and Martian alpha particle experiment, alpha particles were directed at a very thin gold foil. Figure 11.1 shows 5 of the nuclei of the atoms in one layer in the gold foil. Also shown are the path 3 of alpha particles directed to the foil. In question 11 part A, on figure 11.1, complete the paths of the 3 alpha particles. Look at the diagram. These are 5 atoms in a one layer of gold foil, and you have 3 alpha particle. Alpha particles are helium nucleus. That means 2 protons and 2 neutrons. Charge on an alpha particle is +2, positive in nature. In part A, you need to complete the path of 3 alpha particles. For number 1, the alpha particle deflect like this. For second, they go straight, and for third, they deflect backward. And what are the reasons? Look at the first one. Alpha particles are positive in nature, and if they are deflecting down, that means some force on the alpha particle because of these atoms. If they are deflecting, that means the atom contains a positive charge, and similar charge repel each other. That's why the alpha particle deflects down. Look at number 2. Alpha particles go straight, that means some empty. Number 3, look at the deflection, that shows a mass is there at this position. Part B. State the result of the experiment that shows that an atom consists of very tiny charged core containing almost all mass of the atom. In 3 observations, only one observation was there, in that the alpha particle deflected greater than 90 degree or with a greater deflection. That shows that some mass is there. So it is the proof within the atom a very tiny region, in that its whole mass is there. So you can write like this. B2, state the sign of the charge on this core, positive. And the reason is deflection. 3. State what happens occupy the space between these charge cores. One observation was alpha particles go straight. That's confirm the space between the atoms is empty or vacuum. So you can write like this. Nothing between them or vacuum. Part C. The nuclei notation for an alpha particle is this. State the number of protons and neutrons in an alpha particle. Remember this when you write alpha particle like this, 2 and 4. At the bottom you write atomic number represented by Z, and at the top you write atomic mass A. So number of protons are equal to atomic number. So you have 2. So you can write protons 2 here. Then you need to know number of neutron. So you can find the number of neutron like this, A minus Z. A we have 4, Z is 2, then we get 2. So an alpha particle contains 2 neutrons. Thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need in your IGCSE physics. So keep watching Physics with Safdar for better results in exam. See you in the next lesson.